Hi class, this video is still in chapter 3 and we're going to move into section 3.3. This is about parallel lines and angles formed by transversals. So we have two objectives in this section here. What we want to do is first thing we want to prove and use theorems about parallel lines cut by a transversal. And then the last thing we want to do is we want to use algebra to find measures of angles formed by parallel lines cut by some transversal. All right, the first thing I want to do is introduce a theorem. This is the alternative angles converse, or alternate interior angles converse. Forgive me for that. And this is what it says. This is the converse of a theorem from last section. And the theorem last section worked kind of like in the opposite way as this one. But this theorem says if two parallel lines are cut by a transversal, so if we have line L and line M, right, then the alternating interior angles are congruent. So what we're saying here is if line L is parallel to this line M, right, we're saying angles 4 and 6 have the same measure and angles 3 and 5 have the same measure. What we were seeing in last section was if angles 3 and 5 have the same measure, then the lines are parallel. Now this is just saying the theorem in another way, the flip side of that. If the lines are parallel, then the angles are congruent. The alternative interior angles are congruent. All right, so let's talk about finding angle measures. So using the figures shown and given that angle 3 here is equal to 55 degrees, right? Find the measure of all the other angles, right? Tell what theorem or postulate you used, and recall that red line arrowhead notation here means the lines are parallel. All right, so we've got these two lines are parallel and they're cut by some transversal. And all we know is that angle 3 here measures 55 degrees. All right, well, first let's find the measure of angle 5. Well, that is also equal to 55 degrees because they're their alternate interior angles. Angle 7 here, all right, that's also going to be equal to the measure of angle 5, which is 55 degrees. All right, that's by the vertical angle theorem. Measure of angle 4, all right, well, that's equal to 180 degrees minus the measure of angle 3, or 180 minus 55, and that's equal to 125 degrees. All right, that's by the linear pair theorem. Then the measure of angle 2, all right, well, that's going to be equal to the measure of angle 4 by the vertical angles theorem. So we know that that's also 125 degrees. All right, let's do another theorem. This is the corresponding angles converse. So this is, again, a converse from previous theorem and last section. So if we have two parallel lines are cut by a transversal, then corresponding angles are congruent. So if line L is parallel to line M, what we see here is angle 1 must be congruent to angle 5, 2 must be congruent to angle 6, angle 3 congruent to angle 7, and angle 4 is congruent to angle 8. Same side interior or consecutive angles converse. This is a converse again from Theorem 3.2-6 in last section. All right. If two parallel lines are cut by a transversal, then same side interior angles are supplementary, meaning they add to 180 degrees. So if L is parallel to M, then what we see here is the measure of angle 4 plus the measure of angle 5 is 180 degrees. The measure of angle 3 plus the measure of angle 6 is 180 degrees. Again, Theorem 3.3-4, the alternate exterior angles converse, or the converse of Theorem 3.2-7. If two parallel lines are cut by a transversal, then alternating exterior angles are congruent. So if L is parallel to M, then angle 2 is congruent to angle 8, and angle 1 is congruent to angle 7. All right, let's do an example about finding angle measures here. All we know here is given the figure shown and the measure of angle 4, so this one right here, the measure of angle 4 is 42 degrees. All right, find the measure of the other angles. All right, so we're also notice here that the line L is parallel to line M. So if this is 42 degrees, the measure of angle 2 here, well, that must also be 42 degrees by the vertical angles theorem. The measure of angle 6, all right, well, notice that the measure of angle 2 and the measure of angle 6 are corresponding, or measure of angle 4 and angle 6 are alternate interior angles. So that also has to be equal to 42 degrees, right? So that's the alternate interior angles converse that I just talked about. Measure of angle 8, well, that's a vertical angle with measure of angle 6, so that's equal to 42 degrees. All right, now the measure of angle 7, all right, well, that forms a linear pair with measure of angle 8 here. So you're going to take 180 degrees and subtract 42 degrees, so that means measure of angle 7 is 138 degrees. And now notice here that angle 5 is a vertical angle with angle 7. So that's going to be also equal to 138 degrees by the vertical angles theorem. Measure of angle 3 here. Well, notice that's a corresponding angle with measure of angle 7, or an alternating interior angle with measure of angle 5. So that's got to be 138 degrees by the alternate interior angles theorem, Converse. And angle 1 here is a vertical angle with angle 3. So that also has to be 138 degrees by the vertical angles theorem. All right, using the figures shown, what are the measures of angle 3 here and angle 4 here? Which theorem justifies each answer? All right, so first off, we've noticed, forget the typo here, but this is saying that P is parallel to Q here, right? So if the measure of angle 3 must be the measure of 105 degrees by the alternate interior angles converse here. Also, if we know that L is parallel to M here, measure of angle 4 plus 105 degrees must be 180 degrees. Right, so that's by the side-by-side interior converse. So that must be, the measure of angle 4 must be 75 degrees. So we know this is 75 degrees. We know this one here is 105 degrees. So I'm not going to go through the rest, but you could go by and figure out what all the rest of the angles are by that. All right, let's do an algebra problem real quick. So let's use algebra and parallel lines theorem to find angle measures. So I've got this line here, L, is parallel to line M, and it's cut by a transversal here. All right, so we're given that L is parallel to M. I want to find the value of X here. So a solution. The measure of angle 3, what we know here is it's an alternating exterior angle, so they must be congruent, so they must be 105 degrees. So the measure of angle 3 plus X plus 30 degrees must be 180 degrees because they're supplementary or linear pairs here. So we know the measure of angle 3 is 105 degrees. So combine like terms, you get X plus 135 degrees is equal to 180 degrees. Subtract the 135 over, and you get that X must be 45 degrees.